Okay, so we're going to start with 1.4, and we're going to begin by looking at question number 7. Now, on these, I may not work them out completely, but I will get you to the point to where you have the equation. Unless there's extra things at the end that we need to be careful of. Question number 7 is a distance problem. Now remember, when we have these distance problems, there's 3 outcomes. They can add, they can subtract, or they can equal each other, right? So one of the 3 options. Let's look at question 7. A lot of times these are much, much easier than the mixture and the investment problems. So question 7. Jill is 10 kilometers away from Joe, and they begin to walk towards each other at the same time. Jill walks at 2 kilometers per hour, and they meet in 2 hours. How fast is Joe walking? So let's first draw a diagram. What do we know? Well, we know they're 10 kilometers apart, and they're going towards each other like that. So if they're going towards each other like this, then they are going to what? They're going to add together, right? Because they're going in opposite directions. When do they subtract? When they overlap. So if they overlap, they subtract. These do not overlap. Now, what do we need? We need a rate, a time, and calculate our distance. So this will be Jill, or sorry, this will be the first one here. Yep, first one's Jill. And this one will be Joe over here. So what do we know? Jill is 10 kilometers away from Joe. We'll deal with that later on because that's our total distance. Okay, so that total distance is 10. We can write it out now if you want, but we won't use it until later. So if you want to go ahead and write it down and keep track of it, that's fine. But we won't deal with that total distance until later. What do we know about Jill? Jill walks at 2 kilometers per hour, so her rate is 2. We know the times are the same, and they meet in 2 hours. So the time for each one of these is going to be 2. Now, do we know Joe's rate of speed? Does it tell us in this problem at all? No. So that is the unknown quantity, what we don't know. So we're going to use an x to represent Joe's rate of speed. And we know the times are the same, so his time is also going to be 2. Okay, is everyone okay with what we've got? So why are they adding together? Because they're going towards each other, right? When do they subtract? When they overlap. These do not overlap, so they add. Each one has a rate and a time, and we haven't worked with it yet, but over here's our total distance. So now that we know the rate and the time, we can find our distance. Because the distance is going to equal now the rate times the time. So we're going to find the distance that Jill travels. Well, Jill's rate is 2. Her time is 2. And then we're going to add that together to Joe's distance, which is rate of x, time is 2. So that's 2x, and what's our total distance? Well, our total distance here is going to be 10. You should be able to solve it and finish it from here. I don't want to finish it all the way out because I want to leave something for you to work with here, but you've got the equation, right? You just basically take the 2 times 2, which is 4, move it over, divide, and you got your answer. Okay? And x is what we want because x is Joe's rate of speed, and that's going to be in kilometers per hour. Question 8. Very, very similar. to what we just did in question 7. Bert is 22.5 kilometers away from Brenda. They both begin to walk towards each other at the same time. Bert walks at 2.5 kilometers per hour, and they meet in 5 hours. How fast is Brenda walking? Well, just like the last one, they walk towards each other, don't they? So that means, again, just like the previous question, that it's going to be addition. And again, we're not going to work with it yet, but we can go ahead and write down our total distance. And our total distance in this particular problem is 22.5 or 22.5. Now again, we've got Bert and we've got Brenda. They're walking towards each other, so just like the previous ones, or the previous question, addition. They overlap, what would it be? Subtraction, right? And if you're going to work and coming back, they equal each other, you set them equal. In this case, going towards each other, they add. And let's talk now about the rate and the time for each one of these. Now in this case, the times are going to be the same, so whatever one of them has for the time, the other one will have the same time. So they both begin to walk towards each other, and Bert walks at 2.5 kilometers per hour. So 2.5 is his rate. We don't know Brenda's rate of speed, so we'll use an X. And they meet in 5 hours, so that means my time is going to be 5. Okay. Is it making more sense on how we set these up now? The distance ones are very simple once you understand if it's addition, subtraction, or if they equal each other. That's where students sometimes get confused, and making sure everything is documented out. So now we have our rate and our time. We can use those to find our distance. And the distance is the rate times the time. And we've got Bert and we've got Brenda. And then we have a total distance over here. And we know that total distance is 22.5. So that's going here. And what do we know about Bert? Rate times time. So that's 2.5 times your 5. They're going to add together. And Brenda is 5 times x, so that's 5x. And you can finish it from there. Okay, is it kind of making sense how I set these up? So what do we do for these distance problems? We draw our arrows. These are called vectors, by the way, and they indicate directions. We draw our vectors or arrows out. We label them. We see what we're working with and which piece we're missing. Sometimes it might be the times equal. Sometimes it might be the distances are equal. I mean, there's some component that's going to be equal here. We set it up and we find what we're missing. Question 9. Okay. Again, very, very similar. From a point on a river, 2 boats are driven in opposite directions. One at 5, one at 7. And how many hours will they be 36 miles apart? So in this case, they're going in opposite directions. So let's begin with that. Okay, so opposite directions, they're both going to start here. And they're going to go in opposite directions. Now, the previous two questions, they were heading towards each other, right?
Mm-hmm.
They were addition. What about this one? Addition or subtraction?
Subtraction.
No. Do these overlap? Do they?
No.
Okay. So let's go back and review to make sure we understand when we add. We add when they look like this, or going towards each other like this. When do we subtract? Okay. Well, we subtract when they overlap. So two people running a race. This is subtraction because this has got overlap. Okay, so if they overlap like this, it's subtraction. And when are they equal? Are they equal when they're right on top of each other and they're the same? Okay, so when we look at our picture here, they're going away from each other. They're not overlapping, right? When two people run a race, that's an overlap, we subtract, okay? Because one's running faster than the other one, it's going to outrun that. Otherwise, it's addition. So these are going away from each other. So it is a different diagram than the previous two, but it's still the same outcome because it's going to be addition. Going away from each other. So they're driven in opposite directions. And I'm going to label them as 1 and 2. And it says one has a rate of 5 miles an hour, and the other at 7. Okay, and what do we not know here? Well, what we're missing in this case is we don't know the times. We know the distance apart. Okay, so we do know the total distance, which we can write that down if we want. We can go ahead and keep track of that. That total distance is 36. Okay, and we don't know the time, so the times are going to be x. Now, why are they going to be the same? They leave at the same time, right? Time is what we don't know. We know how fast they're going. We know their total distance. But what we're missing here is we're missing the number of hours it takes them. And that's what we want to find. And we know they're going to be the same because they start at the same time. So if one's in the water for 5 hours, the other one's going to also be in the water for 5 hours, right? They're going to be the same. So now what does our equation look like? Well, we use our distance formula again. And distance is the rate times the time. And so our first one is going to be 5x, right? Because that's 5 times the x there. We're going to then add that to the second one, which is 7x. And what does it equal? Yep, total distance. $36. Okay. And so you can finish it from here. Is everyone okay with how I set it up, though? Now, do we understand completely the difference between addition, subtraction, and equals? Most of the time, there'll be addition. Once in a while, though, there'll be subtraction, which is not very often. Any type of a race, if they're running a race or something, that is subtraction. Or if you have like current pushing back on a boat or wind pushing back on an airplane, that's going to be subtraction. And if they equal each other, this would be like going to work and driving back home. You're going to drive the same distance. So they would be equal. Question 12. Question 12, we're going to have to think about how to set this one up. Okay, on this one, what we're doing is we're taking a trip to St. Louis. So Tom traveled 200 miles east of St. Louis, and for most of the trip he averaged 70, but for one period of time he was slowed down to 10 due to a major accident. If the total time was 8 hours, how many miles did he drive at the reduced rate of speed? Okay, so what do we have? Well, we have a trip, and this trip is going to be broken up into two parts. And the first piece that we encounter is that 200 miles. So that's my total distance. So my total distance here is going to be 200. So we'll deal with that here in a few minutes, but distance is usually the last thing that we work with. So we've got our trip broken up into two parts. We know our total distance is 200. And for most of the trip, he averaged 70. For one period, he was slowed down to 10 for an accident. So most of the trip, he's going to be on the highway at 70 miles an hour. And then he hits a major accident, and that slows everything down to 10. So that's what we've got so far. By the way, this is going to be addition. Why? Because if you think about it, if you're driving on a trip, you've got the first half here, which you're driving at 70. You hit an accident over here, they're going to add together, right? Because that gives you your total trip. So again, this is going to be addition, because we're going to put these two pieces together, and that's going to give me my total trip. So trip part A and part B, and put them together. What we need to think about here and find is how long we spend in each one. Now, this one's a little bit different because we know our total time is 8. So we know we're on the road for 8 hours. Now, we don't know how it's actually split up, but we do know that we're traveling for 8 hours here. What about the time that we're traveling at 70? Does it tell me how long I'm traveling at 70 for at all? No. What do we know? We know the total time, right? We know it's 8 hours for this entire trip. So do we know how long we spent driving at 70 on the highway? No. Okay, so that's going to be our unknown. So we're going to call that one X. Now, do we know how long we were in the accident for? No, that's not known either, is it? But we can't just use that X again. So we're going to look at it as 8 minus X. And why are we looking at it as 8 minus X? Well, that is your total minus X. Remember when we did the mixture problems, right? And you knew the amount in one container but not the other one. Or the total amount, and you didn't know the amount in each container. So you called one of them X, remember that? And the other one was a total minus X. So if you had 100 liters total, you called the first one X, and the other one 100 minus X. Remember that? Same concept here. Unknown amount of time at 70, we don't know. Unknown amount of time driving in the accident, we don't know. But we can't use X twice. So one of them is X, the other one is going to be the total minus X, which in this case is 8, because 8 goes with our time. And when we add these together, one X is positive, one X is negative, they cancel out, and that gives you 8, which it should be. It should be total time of 8. Now we can build our equation. And I'm going to work this one completely out, because this one asks you to find an extra component. It asks the number of miles. So we're going to work this one completely out so we can understand what we're looking to solve. So let's go ahead and work with our distance. Distance, again, is the rate of speed times the time. Our first one. Rate of speed is 70. Unknown amount of time, x. Second one. 10 miles an hour. Time, 8 minus x. What's the total distance again?
200.
Yep, so that's going to go down here. Where students sometimes make a mistake is they get the times and the distances mixed up. Distance is going to be the very last thing that you work with. The very last component is that total distance. Now we're going to go ahead and solve this out, and I'm going to work through this one because what we find for x is not going to be our complete answer. So I'm going to go ahead and work this one out. And that's 70 distributing through plus 80 minus 10x equals that 200.
Okay, good.
Okay, combine everything together. We get 60x, right, because those can go together, plus 80 equals that 200. We'll move our 80 over. So 60x equals now 120, doesn't it? And we'll divide by 60. And we now end up with x equaling 2, isn't it? Okay. Now, what does it actually want? And what does that x represent? Okay, this x equals 2. What is that? That is the time. That's not miles, right? What is it? Let's go back up and look at our picture. X represents the time at what? 70. So x is the time at 70. That is not what we want, though. Okay? What we want is we want to know how many miles he drove at the reduced rate of speed. Okay, this is what we want here. That's not what we're given yet. Okay, so we want the miles driven at the reduced rate of speed. So when we talk about the time at the reduced rate of speed, we're going to have to calculate it out. Well, when we're looking at the reduced rate of speed, that's the second one. Okay, and how fast are we traveling when we're in that accident? Rate of speed on the second one is going to be 10, right? This is the reduced rate of speed, 10. What about the time at the reduced rate of speed? Well, it's 8 minus x, which is then 8 minus 2, which is 6. Now we need to finish this problem out. How do we find our distance? Distance is rate times time, and that is 10 times 6, which is now 60. So that's what we want for a final answer. So we drove 60 miles in this accident. Okay. Now, we can quickly check. While you're working this one out and while you're writing it out, I'll talk about how we can check it. Now, for the first half of this trip, we were traveling at 70 miles an hour. And we did that for, in this case, 2 hours. 70 times 2 is 140, right? 140, we add on that 60, we end up with our total miles, which is 200, okay? So that's what we wanted. We know it makes sense because when we add the total miles together, we get 200, which is what it should be. Does everyone see why we couldn't just stop here? X was not what we wanted. That was the time at 70, but we didn't want that. We want the number of miles driven at that reduced rate of speed. So we have to write down the rate during the accident, find the time, multiply them together, and that gives you now how many miles we drove at that reduced rate. I picked question 14. Question 14 is a very, very easy question, but it is actually one of the most commonly missed questions. What happens is students don't finish it out completely. They only get part of the answer. Whenever we work with these angle problems, when we find our variable, that's not the end of it. Because we have to make sure that we take it and plug it back in to get the two angles. So this is what's called a complementary angle. So there are three types of angles. There are supplementary, and supplementary looks like this. Okay, that's like question 13. Question 13 is supplementary. They would add together to give you 180. Okay, it's not what we have. There's complementary. This one's complementary. They're 90 degrees, so they add to be 90. What about question 15? It's a triangle. They sum to 180. And what about 16? These form an X, so what do you know about 16? These would equal, wouldn't they? Right? So you see there's actually four different types. They can either add to be 180 for a supplementary angle, add to be 90. Triangles 180, or vertical angles form an X and they equal. So this is called complementary, so that means these sum to 90. Writing it out, we've got 4n plus 14n minus 72. That equals 90. Okay, those are complementary. Go ahead and combine. 14 and 4 makes it 18n. I'm going to add my 72 over. And you can do it in multiple steps if you'd prefer. I'm going to go ahead and add that 72 over. And that gives you a 162. We'll divide by 18. And n now equals 9. Okay. This is a question like you're going to see on your exam. If you got to this point and left n equals 9 as your answer, you would probably only get about half credit. What do we need to do to finish this one out? We need to, plug it in, and we need to find the two angles. This is a very easy question. I like to put these type of questions on your exam because it makes you go back, plug them in, and they're pretty easy to work through. So what's our answers going to be? Well, our answers are going to be plugged back in. So our first one is 4n, which is 4 times 9, which is 36 degrees. So there's your first one. We need to get the second one. What's the second one? That's 14 n minus 72. So that's 14 times 9 minus 72. And that gives you then 54. How do we know that we did it correctly? They should add together to give you now what? 90. Do these add up to give you 90? Yes. So this is an easy question. I don't want you to miss this type of question on your exam. All you have to do is solve it, find the piece, plug it back in, get the two solutions. If it's a triangle, you'll get the three of them. That now takes care of 1.4. Moving on, we're going to look at 1.5, which is inequalities. And just as a quick review on these inequalities, let's remember strictly less than, strictly greater than. Those get parentheses. Greater than or equal to, less than or equal to, those are going to get your square bracket. And also positive or negative infinity, those get parentheses as well. So that's what we need when we look at interval notation. They're either going to be square brackets or they're going to be parentheses. Question 3. We've got 9x plus 6 over 8 is less than 22 over 3. Okay, now, we can solve this the exact same way we can solve an equation. The only difference is when we work it out, at the end, we don't have a number answer, we have a range. We have an interval notation and a graph. So we can use the same procedure to clear out our fractions. So we can cross multiply. So we're going to go ahead and cross multiply. So we've got 3 times 9x plus 6. Now the inequality symbol stays the same. And then we've got 22 times 8 here. That's going to clear out my fraction. So I just cross multiply. Nothing changed with the inequality. When do I flip my inequality symbol? When you multiply or divide by a negative, right? You didn't do that. Everything was positive so far. So now we just distribute that 3 through. And that is 27x plus 18. And the other side is 22 times 8, which is 176. Okay, so we just simply cross multiply. That's all we did. Move that 18 over. And when we move that 18 over, that leaves you with 27x is less than 176 minus 18, which is 158. Divide by the 27. Are we going to flip our inequality sign? Yes or no?
No.
No. Why not? What are we dividing by? Positive 27. When do we flip it? When it's negative. So the inequality symbol stays the same. And then 158 divided by that 27. Not going to reduce down much at all. Okay, 27 only breaks up into 3s. 158 does not have a 3 in it at all. So you can just leave this then as 158 over 27. So just leave it as that. It's not going to break down any because 27 only breaks down into 3s. Right? And 158 does not have a 3 in it at all. How do we graph this? Well, we draw a number line here. And we've got 158 over 27 here. And what do we know? Which way does it point? Okay. It is pointing to the left. So that's where we shade. Okay. And what do we have? Brackets or parentheses here? It looks like there's no bar underneath. So it looks like it's going to be parentheses. And we're going to be going out in this direction. And where does it go to? Negative infinity. So how do we express our final answer? In interval notation. Read it from left to right, just like you're reading a textbook. Negative infinity with parentheses. And where does it go to? 158 over 27. Also with parentheses. Most of the time, they're going to come out to be whole number answers, but this one didn't, right? If you get a fraction, that's okay. You can have fractional answers, and that 158 over 27, it's not going to reduce at all. So we just leave it the way it is. I'd rather you have a fraction than a decimal, so just keep the fraction. If it doesn't reduce, it doesn't reduce. Similarly, question 6. We've got a three-part inequality. And how are we going to handle this one? Well, we're going to work it out the same way we did the previous one. We need to clear our fraction. And the only fraction that we have is a what? Is a 7, right? 7's down below, right, in that denominator. So we've got that 3x minus 1 over 7, so that's our fraction. How can we clear out the fraction? Yep, we can go ahead and just multiply everything by a what? By a 7, okay? You can, however you want to remember to do this, all you have to do is just multiply everything by 7. So we're going to multiply everything by a 7. And you can draw arrows across multiply that way, however you want to remember that everything gets multiplied by this 7. So what do we have here? Well, 6 times 7, that's 42. This 7 and this 7, they cancel out. Okay, so they're gone, right? That entire part cancels out, and that leaves you with a 3x minus 1 in the middle. On the right-hand side, we have 9 times 7, which is a 63. So we didn't multiply that 3 times the 7, right? What did we do? We just canceled those out, right? Because they're gone. You could also draw it as just arrows if you want to multiply it that way. Okay, but all it does is kill that fraction, so we don't distribute it through, we just kill the fraction. Now we can finish it. Add our 1 to all 3 sides. And then we've got 43. We have a 3x in the middle. And it looks like we have a 64 on the right-hand side. And these may or may not reduce down. I don't think that they will. Nope. So that's going to be, we'll divide everything by 3. So that's going to now be 43 over 3. We've got an x in the middle. And we've got a 64 over 3 on the right. And nothing's going to reduce down at all. Is everyone okay with how I did that? And most of the time you're going to get whole numbers, but if you get fractions, that's okay. A lot of times students think they should always get whole numbers. That's not going to be the case. Most of the time you'll get whole numbers, but sometimes you will get fractions. So we just simply got rid of our fractions. We moved that 1 over. Now, how do we graph it? Well, x is between those two numbers. So 43 over 3 and 64 over 3. These have the equal bar underneath, right? So they're going to get brackets. And we shade in the middle. And so then what does our answer look like in interval notation here? It looks like 43 over 3 with the square bracket, comma, 64 over 3, also with a square bracket. Is everyone all right with that so far? I think you'll find the inequalities to be much, much simpler than the applications. And today we're going to do more of the inequalities. We're going to be looking at some absolute values. We've got 2 more questions out of 1/6 to look at. And then we'll take a break, come back, and do 1/7. So 1/6, we're going to look at question number 6. Now let's just review a little bit about the and the or. An and is also called an intersection. It's where they intersect, where they cross. And what we do with that is we look at where they overlap. So our answer is going to be the overlap part. So when we talk about an and, that's also called an intersection. And our answer is going to be that overlap part. Now, what about an or? Or is called a union. Like a marriage. Everything gets united together, combined together. And what's the answer going to be? The answer is going to be combined together. So we're going to be combining the parts together. And how do we combine them together? We use a U to represent that union. So an and is an intersection. It's where they overlap. Our answer is going to be the overlap part. Or is the union. And that's where they get combined together. So for question 6, we've got minus 5x plus 1 is greater than or equal to 11, or 3x plus 3 is greater than or equal to a negative 9. This is going to illustrate another concept about inequalities. When do we flip our inequality symbol? When we divide by a negative. And we're going to be doing that in the first one. Because when we have to divide by that negative 5, that's going to flip your inequality symbol around. I always like to just draw a line here so we can separate them out. And move that 1 over. So we'll do the left inequality first. So moving that 1 over, we have a minus 5x is greater than or equal to 10. We'll divide by our negative 5. Now that's going to force your inequality symbol to flip. So make sure you flip that inequality. And 10 divided by negative 5, well, that is a negative 2. Make sure you flip that inequality, though. Now we're going to do the other one. Move the 3 over. 3x is greater than or equal to negative 12. Divide by our 3. Do we flip the inequality?
No.
Nope. Why not?
Not dividing.
Right. Dividing by a positive 3, not a negative 1. We put them together on the same number line. And I'm just going to use different colors here to kind of represent these. So the first one I'll do in green. Hopefully we can see the difference here. Okay, the first one is negative 2. And it's pointing back to the left. So we'll put negative 2 over here somewhere. And it's going to point back to the left. And we're going to use square brackets. And the other one, we have to be careful. Make sure you put them in the right order. Okay, negative 2 is here, so where's negative 4 going to be? It's going to be back to the left, isn't it? So it's going to be over here somewhere. And which way is it pointing? Okay, it's pointing to the right, and we're going to use a square bracket. Now, what is my answer going to be? Well, we're going to combine everything together. If it was an and, If this was an and, it would be the overlap part here, okay? But this is not an and, this is a or. And if I look at it, what happens if I put the green and the blue region together? It covers the entire part. So it covers everything. So it covers the entire line. So that means my answer would then be negative to positive infinity. Right? Because we had to cover the entire line there, and that was an or. If it was an and, again, it would be in this piece right here. Ours, though, is an or. One more, and then we'll take a short break. Last one of these questions is question 7, and it's another or. And we've got to make sure we read the directions. So it says on question 7, for the inequality, decide whether it's an intersection or a union, and then give it in both interval and graphical form. So ours is an or. What does an or go with? Union. So the first part is going to be, this is going to be a union. And it asks for that, so the first part is going to be the answer of union. So it is a union. And then what do we have? We have 4x plus 2 is less than or equal to a negative 6, or 4x is greater than or equal to negative 4. So we know it's a union. We're going to be uniting the pieces together. Watch your symbols. Watch adding and subtracting. A lot of times on this type of question, students make a mistake because they get in a hurry and they add instead of subtract. So we're going to start on the left-hand inequality. We're going to move that 2 over. And that leaves me with 4x is less than or equal to negative 8. We'll divide by our 4. And so x is less than or equal to negative 2. No need to switch the inequality because we divided by a positive 4, not a negative 4. On the right-hand side, a lot of times students will make a mistake with this one. Now, when do we flip the inequality? When we divide by a negative. We're not dividing by a negative, are we? We're dividing by a positive 4. But a lot of times students will look at this negative and they'll rush through things and they'll flip the sign. We do not flip the sign because we are dividing by a positive 4. So that means the inequality symbol stays the same. And the right-hand side is going to be a negative 1. So we didn't flip it. A lot of times, though, I see students do that. Now we put them on our number line. And we've got a negative 2. So negative 2 is about here. And it's pointing to the left. So we'll go ahead and shade back to the left. And it has the equal bar underneath. So that means we've got a square bracket, doesn't it? And then we've got the negative 1, which is on the right, because negative 1's a bigger number. And this one here is pointing to the right. So we shade there. Now, what do we need to do? We need to put these together. If this was an and, you'd have no solution, right? Because an and would mean where they overlap, these do not overlap at all. We, though, have an or. Or means we want a union. So we're going to unite the pieces together. So how do we do that? We use a U. So this one is negative infinity on the left, positive infinity on the right. So we have negative infinity, comma, negative 2 with our square bracket. Now, how do we put them together? We can't use a plus symbol because these are our sets. So what do we have to use? U for union. And what are we going to unite that with? -1. And where does it go to?
Infinity.
Positive infinity. So that would be your answer in interval notation. So it's a union. And there's the answer in interval notation. Okay, let's take a short break, and we'll meet back here at, let's say, 9:40. So meet back here in about 15 minutes, and we'll start the lecture back at 9:40.